Hello, everyone. This is Kashif Pamo. I'm from Electrical and Electronics Engineering Department, California State University, Sacramento. I'm presenting today. I'm presenting a project we have established for Eee174, our microcontroller lab. My current project is extreme temperature warning. I'm presenting this project with my team members, Andrea Schmecken and Arnold Dolan. A little bit introduction of the project. My project is very useful in our daily life, and we're using industrial equipment. That the project will monitor the temperature of an equipment or of a system, and it will work according to the temperature. Let's say in case of temperature risk and it's harmful for the device or the system you're using, my project will continuously checking temperature, so it will sense the temperature and sense the overheat, and it will turn on the cooling system and will turn on the warning lights, and cooling system will be turned on until the temperature is normal to the circuit or the device or the system we are using. And similarly, for the high temperature, if the temperature goes low, then it will turn on the heating system. Scope for this one, the why we are doing this project, we can understand the working of a temperature control, how we can implement the hardwares and softwares, and we can understand the communication protocols and how the software will work according to the program, and according to the hardwares, how the hardwares will talk to the program. That's all the learning scope of that project. If we talk about the block diagram of that scope, the project, we are getting the input from the temperature sensor. It will be analog, and that feeds to the STM32 board. The STM32 board will decide what to do. It will change the data to digital, and it will decide if it has to turn on the heating system or if it has to turn on the cooling system accordingly. Next, I will hand over to my team member, Dolan Arlen.
Nice to meet you. For the temperature sensor, it will be continuously monitoring the entirety of the project itself, and the temperature sensor will feed the input to the board. Once it hits certain temperatures, it will automatically either cool the system down if it gets too high or heat it up if it gets too cold, because either or will actually ruin a machine or a circuit. Next slide. This is the FSM diagram of the circuit and what temperatures we'll be planning to use for the project itself. This will be a good demonstration with the LEDs representing the heater and the cooler respectively. Next slide. For the board that we'll be using for the project itself, it's an F303K8. And to use it, we'll be using the STM32 project, which mostly focuses on the C++ programming, as well as GPIO inputs, outputs, and alternating inputs. And it's also accessed by other such things like UART, SPI, and others. Next slide. There are multiple ways we could have improved the project, though we did run out of time. We could have actually added in a voltage sensor if we had the parts for it, so we could correlate the amount of voltage to how much heat was generated in the project itself. We could have also included multiple heat sensors to see how the heat was affecting the board and how hot it was getting in certain regions of the project. And lastly, we could have just created a cleaner code so more modifications and more stuff could be added in, because all projects get updated and all projects have that tiny bit of errors, so it was most definitely needed, possibly. Next up, Andre.
Everyday application of this device can be seen in everyday life is in industrial equipment, home appliances, small appliances, vehicle components, HVAC, agricultural industry, medical equipment. Thank you for your time.